everyone, this is Nirali. Welcome to the world of the chemistry. So now you all are in a third semester, right? So before we discuss our today's topic, firstly, I will give you a basic fundamental information related to our syllabus, like how many units are there, how many chapters you're gonna be learn, what are the core subject, what are the practical subjects, right? So you can get a basic idea about that. So this is your scheme of examination. You have three subject, core subject and practical subject, right? And you have a two exam, external exam and internal exam, you already know. Now you have a three units: unit 1 inorganic chemistry, unit 2 organic chemistry, and unit 3 physical chemistry. In this, I gonna be learn you inorganic chemistry as well as physical chemistry. So now our unit number 1, chapter number 1 and 2. So your chapter number 1 is wave mechanics and MO theory. Tarang and MO theory. MO theory, that means molecular orbital theory, જે તમે first semester માં already ભણી ચૂકેલા છો, right? So introduction of wave mechanics, postulate of wave mechanics, interpretation of psi star, psi square, derivation of Schrodinger equation in 3 dimension, you all know, right? Eigenfunction and eigenvalue, this is new for you. Orthogonal and normalized wave function, concept of molecular orbital theory, characteristic of molecular orbital, wave function of H2 plus and H2, potential energy and Schrodinger equation of H2 plus and H2, derivation of normalized wave function of H2 based on a molecular orbital theory, and last one, derivation of coefficient of wave function of sp, sp2, sp3 hybridization with bond angle. You all know sp hybridization, what is sp2 hybridization, what is sp3 hybridization, right? Hybridization means સંકરણ, s અને p orbital નું સંકરણ. sp orbital એટલે કે 1s અને 1p, sp2 માં 1s અને 2p, sp3 માં 1s અને 3p orbital નું સંકરણ, right? So moreover, chapter number 2 is chemistry of elements of first transition series and first inner transition series. Now you all know our Avart Kostak, right? So in this transition series and first inner transition series. So first 3D transition series, introduction, position in the periodic table, that means Avart Kostak, electronic configuration, that means any rachna, reversal of energy of 3D and 4s orbital, physical property such as atomic properties, atomic ready, ionic ready, ionization potential, oxidation state, metallic conductivity, melting point, boiling point, density, right? Reducing properties, tendency of formation of alloys, alloys that means combination of two metals, catalytic properties, magnetic and spectral properties, oxidize and oxoenzymes of transition metal, calculation of magnetic moments of ion of 3D series metal. This is 3D transition series. Now 4F inner transition series. Introduction, position in the periodic table, occurrence and importance ores, individual isolation by ion exchange method, solvent extraction method, right? Electronics configuration with necessary explanation, oxidation state, their stability, magnetic property, color, isotope, and spectral properties, right? Lanthanide construction, use of lanthanides and their compounds. Now I will take your chapter number 7, equilibrium. First we will start equilibrium, right? Introduction, criteria of phase equilibrium. So first of all, you need to understand what is equilibrium, what is phase, explanation terms, phase, components, degree of freedom of system, therefore Gibbs phase rule, limitation of phase rule, phase diagram of one component system is water and sulfur system. Then after two component system, eutectic system માં lead and silver, and congruent melting point system Mg and Zn, and incongruent melting point system Na and K. So we will discuss first this chapter, phase equilibrium, right? Then after your chapter number 8, solution. In this, affecting solubility, types of solution, types of liquid-liquid solution, miscible liquid pair, immiscible liquid pairs, right? Solution of gas in a liquid. Then after your chapter number 9, Nernst distribution law. What is Nernst distribution law? What is the limitation? Method, modified Nernst distribution law, application, solvent, extraction, and then after numericals, right? So here there are a list of reference book. This reference book also available in our library. So you all are use these reference books maximum, right? And this is your practical. Organic qualitative analysis and organic volumetric analysis. You all know organic qualitative analysis, બરાબર? Identification of organic compounds through the functional group analysis and determination of melting point and boiling point, right? And organic volumetric estimation, volumetric analysis, that is very easy practical. So our today's topic is phase equilibrium. So you need to study phase equilibrium or you need to study any other topic. First of all, you have to understand the meaning of topic itself. So here two words, phase and equilibrium, right? So some table context here. First of all, introduction, then after phase equilibrium, then after explanation of terms. First one is phase, second one is component, and third one is degree of freedom, right? Then after Gibbs phase rule, phase diagram of one component system, એટલે કે એક component present હોય એવી system, water and sulfur system. Further, two component system in which first one is eutectic system, lead and silver, second one is congruent melting point, third one is incongruent melting point, right? So now introduction. Now what is phase? Phase કોને કહેવાય? So it is relevant to heterogeneous system. So first of all, you need to understand what is homogeneous and what is heterogeneous, right? Any part of system which is physically distinct and mechanically separated from other part of system, this is called phase. This is a definition of phase, right? So you think, what is system? Now system is the set of substance and energy that is being studied. એટલે કે જેની તમારે સ્ટડી કરવાની હોય, જેનું તમારે વર્ક કરવાનું હોય, એને આપણે શું કહી શકીએ? સિસ્ટમ. અને એની આજુબાજુનું સરાઉન્ડિંગ, રાઈટ? ફોર એક્ઝામ્પલ લઈએ, રિએક્શન આર અકરિંગ ઇન અ જાર, એટલે કે જારમાં કોઈ રિએક્શન થઈ રહી છે, બરાબર? એન્ડ એવરીથિંગ ઇનસાઇડ ઇઝ ધ જાર ઇઝ સિસ્ટમ, એટલે કે જારની અંદર જે બી કંઈ થઈ રહ્યું છે, ધીસ ઇઝ સિસ્ટમ, કે જેની આપણે સ્ટડી કરવાની છે, રાઈટ? અને એની આજુબાજુનું outside of the jar is the surrounding, right? For example, in your classroom, how many benches over there, how many fans over there, how many lighting over there, બરાબર? So your classroom is being to studied, so your classroom is system and your college is surrounding, right? So phase can be a solid, liquid or vapor, એટલે કે phase ઘન હોઈ શકે, પ્રવાહી હોઈ શકે અને વેપર એટલે કે gaseous form માં હોઈ શકે, right? કે જેને આપણે physically distinct, physically અલગ અને mechanically બી અલગ કરી શકીએ, તો એને શું કહેવાય? phase કહેવાય, right? Moreover, what is homogeneous? Homogeneous કોને કહેવાય? Homogeneous mixture કોને કહેવાય? Right? A homogeneous phase is a single phase of matter where everything is a solution. Physical state change હોય, બરાબર? A homogeneous mixture is a solid, liquid or gaseous mixture that has the same proportion of its components throughout any given sample. Right? એટલે કે જેને એક જ phase હોય એને આપણે શું કહી શકીએ? Homogeneous કહી શકીએ, right? For example, air. There are many O2 here, N2 here. We cannot identify this portion is O2 and this portion is N2, બરાબર? So air is throughout one phase. Water. Then after salt water, if we have one vessel, we take a water, we add lemon, we add sugar, we add salt, right? And we make lemonade. This is called homogeneous. All alloys, like all metals are homogeneous. Right? કે જેને સિંગલ ફેઝ હોય, એક જ ફેઝ હોય, એને શું કહી શકાય? Homogeneous phase. Right? Furthermore, what is heterogeneous? The heterogeneous mixture has a non-uniform composition and has two or more phases. કે જેને એક કરતા વધારે phase હોય, એને આપણે શું કહી શકીએ? Heterogeneous કહી શકીએ, બરાબર? It can be separated out physically. For example, when oil and water are combined, they do not mix evenly, but instead from two separate layers. You all know. પાણીમાં તેલ નાખો તો એ આખું મિક્સ નહીં થાય, but separate layer બનાવશે, right? There are lots of example of homogeneous and heterogeneous, right? So your homework is example, give me an example of heterogeneous and homogeneous, right? So this is your homework. So here figure of homogeneous and heterogeneous. First one is homogeneous, water and salt, and another one is heterogeneous, water and sand. એટલે કે આપણે પાણીમાં માટી નાખીએ તો આપણે we can see our naked eyes the particles of soil, sand, right? So this is a picture of homogeneous and heterogeneous. Now what is phase equilibrium? Phase equilibrium is the study of the equilibrium which exists between or within different state of matter, namely solid, liquid and gaseous. Equilibrium, it is defined as a state when chemical potential of any component present in the system stays steady with the time. Now, equilibrium એટલે કે સંતુલન. If we have a two reaction, reversible and irreversible reaction. First one is irreversible reaction. That means A plus B, it gives C plus D. That means 1 mole of reactant converted to 1 mole of product only. The another one reaction is reversible reaction. That means 1 mole of product converted into 1 mole of 1 mole of reactant converted into 1 mole of product, and also product converted to reactant. But at one point, the rate of reaction of reactant and product will be the same, will be the steady with time. This is called equilibrium. This is what we study in this chapter, right? So now here some example of phases, system and phases. There are ice and water. They form two phases, ice in a solid phase and water in a liquid phase. Another one is water and water vapor. This is also form two phases, water in a liquid phase and water vapor in a gaseous phase, right? The another one is ice, water and water vapor. They have a three phases, one ice solid phase, water liquid phase and water vapor gaseous phase. Moreover, two immiscible liquids, for example carbon tetrachloride and water, they both are liquids but they form two phases because they two are immiscible to each other, right? So they form two phases. એટલે કે કાર્બન ટેટ્રાક્લોરાઇડમાં વોટર નાખો તો બે ફેઝ જોવા મળે, બરાબર? બે લિક્વિડ છે તેમ છતાં બી, રાઈટ? Are you getting my point? So now, solid plus liquid, solid plus gas, liquid plus gas, two solid or two immiscible liquids constitute two phases. એટલે કે એક ઘન પ્લસ એક પ્રવાહી, એક ઘન પ્લસ એક ગેસ અને એક લિક્વિડ એટલે કે એક પ્રવાહી પ્લસ એક ગેસ અને ટુ ઘન or two immiscible liquids create two phases, right? But different solids are regarded as a different phases. એટલે કે જેટલા ઘન present એટલા phase present. This is most important line, right? So moreover, what is particularly liquid phase? So the number of liquid phase depends on the number of liquid present in their miscibility. So if two liquids are immiscible, they will form a separate liquid phase. એટલે કે કોઈ બી બે લિક્વિડ એકબીજામાં મિશ્રણ ના થતા હોય તો તે બે લિક્વિડ ફેઝ ક્રિએટ કરે, રાઈટ? ફોર એક્ઝામ્પલ બેન્ઝીન એન્ડ વોટર. વોટરમાં બેન્ઝીન નાખે તો એ મિશ્રણ ના થાય, એ બે ફેઝ જોવા મળે, રાઈટ? Another one is if two liquids are miscible, they will form a one liquid phase. એટલે કે એકબીજામાં મિશ્રણ થતા હોય તો એક જ ફેઝ જોવા મળે. Very famous example, alcohol and water. વોટરમાં આલ્કોહોલ નાખીએ તો they miscible. We cannot identify alcohol and water exactly, right? So moreover, what is solid phase? As I tell you above, each solid form a separate phase. એટલે કે જેટલા solid હોય એટલા separate phase જોવા મળે, right? The number of solid phase depends on the number of solid present in it. For example, many forms of sulfur can exist together, but there are all separate phase. એટલે કે ઘણા બધા સલ્ફરના રૂપ આપણને જોવા મળે, બરાબર? But they all are separate. Now, what is gaseous phase? This is truly miscible in all proportion. It will form only one phase. For example, as I tell you above air, we cannot identify in the air that there are this portion are O2 and this portion are N2. This is truly miscible, right? So these form only one phase. So some other example I will give you. At a freezing point, water consists of three phases: solid, liquid and gaseous. એટલે કે વોટર આપણને ત્રણ સ્વરૂપમાં જોવા મળે. સોલિડ એટલે કે આઈસ, લિક્વિડ એટલે કે વોટર and gaseous એટલે કે water vapor, right? તો તે કેટલા phase જોવા મળશે? Three phases, right? A solution of substance in a solvent constitute only one phase. એટલે કે કોઈ સોલ્યુશન આપણે સોલ્વેન્ટમાં બનાવીએ અને તે મિશ્રણ થઈ જાય તો એ એક ફેઝ જોવા મળે. For example, sugar solution in water. In this example, water is your solvent and sugar is your solute, right? The solute and solvent gives a solution. Another one is an emulsion of oil in a water form two phases. એટલે કે વોટરમાં આપણે ઓઇલ નાખીએ તો બે ફેઝ જોવા મળે. Another one is reaction CaCO3. It gives CaO plus CO2. એટલે કે CaCO3 solid form માં it forms CaO also solid form and it also forms CO2 is a gaseous form. So the system has three phases: solid CaCO3, solid CaO and gaseous CO2. Because as I tell you above, each solids gives each phases. એટલે જેટલા solid present એટલા phase present. So over here three solids present, so two solid present, so here two phase also present, right?